Welcome! In these two videos we will show you how to use the script PhylogenomicSearch.run. This script facilitates parsimony tree searches for phylogenomic datasets. It includes a wide variety of options to perform those searches. For the examples presented here, we will use a dataset from this paper by GUI and colleagues. The dataset has these dimensions. In this first video, I will explain you how to run the script from the GUI version, while in the second video, I will explain how to use the script from the console. To run this script, we do not need to load a dataset beforehand. So in the GUI, we can go directly to the menu File, Open Input File, and choose the script file. Then a dialog box is opened to choose the data file, the alignment. Remember that if you have your data in separate FASTA or Nexus files, you can generate a single TNT file using the script compilegenes.run that we explained in a previous video. Once we have chosen the data file, another dialog box is opened to define the setting of the tree search. The first thing that the user could define is the treatment of the gaps, to treat them as missing data or to treat them as a new or additional character state. The most common practice is to treat the gaps as missing. However, for this example, I will treat them as additional state. Then, the user could define the outgroup. By default, the outgroup will be the first taxon in the matrix, the taxon 0. There are two different ways to define a different outgroup, either by using the number of the taxon or by using the name of the taxon. Here, I will use the species megaceros as the outgroup. Now, I will define one of the most important settings, the tree search settings. Here, the user has two major options. One of the options is using a new technology search. It means a combination of very fast algorithms for complex and big datasets. These algorithms include parsimony ratchet, sectorial searches, tree fusing, and tree drifting. The links for the papers describing these algorithms can be found in the description of this video. The second option is using traditional search. It means Wagner trees by random addition sequences followed by tree bisection and reconnection rearrangements. In both cases, traditional search and new technology search, it is possible to define a level of search strength from 0 to 10. The fastest and least accurate is 0, and the slowest and most accurate is 10. Although you will need to tune these values for your own dataset, we have found that with the levels 1 or 2 is enough for most phylogenomic datasets. If the new technology option is chosen, it is also possible to define the required number of hits to the best length. In this example, I will use the new technology option with the level 2 and 1 hit. Now the user should define the weighting scheme against homoplastic characters. Here it is possible to use equal weights for all characters or to use an implied weighting approach. If we choose implied weighting, we can also modify the weighting settings by clicking Define Settings. Then, an additional dialog box is opened. Here we can choose a weighting scheme among three options. The first is weighting by genes, It means extended implied weighting using the average homoplasy of each loci to define the weights of the characters belonging to the corresponding loci. The second way is weighting by column position. This scheme is similar to the previous one, but the average homoplasy of each column position is used. Caution should be taken with this option, because you need to have every gene in the correct reading frame. For example, gaps may modify it. And the third is weighting individual sites. It means that the weights of each character will depend only on its individual homoplasy. Here I will use this later option. Then we need to specify the strength of the weighting against homoplasy. In this respect, there are two different ways for that. The first is by using a defined k-value, concavity value. This is the traditional way of working with implied weighting. And the second way is by using a defined n-value, an accepted range of weights. I will use the default here. I mean a defined n-value of 15. Here I want to make a post to recommend you 3 articles about the theoretical foundations of character weighting. These papers are free access and could help you to define in a proper way the settings regarding character weighting of this script. The first one of them is this one by Goloboff in 1993. The second is this one by Goloboff and colleagues in 2008. And the third is this one by Goloboff in 2014. Now, the last part of the settings are related to the output files produced by the script. For this example, I will uncheck the option Save Best Tree in a file. But I will calculate and save the street consensus in a file called consensus1. I will save the trees in both TNT and NEWIC formats, and I will generate a SVG graphic with the street consensus. Finally, I just need to press OK. This script takes approximately 50 seconds to run the analysis for this dataset. However, I have already the results here. Here you can see the SVG graphic with the street consensus. And here there are the files with the street consensus in parenthetical notations in both TNT format and NEWIC format. We can open the resulting tree in NEWIC format using, for example, the program fig3, as you can see here. So this is the end of this tutorial. It means this is the end of the first part of this tutorial, and thank you, and see you in the continuation of this tutorial, where we will show you how to use this script in the console version of TNT.